Hi, in this video, we're gonna discuss about the statics in general. Why, as an engineer, you will study statics and what is statics, right? So first of all, statics, as the name suggests, it's a rigid, it's without deformation. Uh, so normally in this class, you can work out those problems using just using pencil and pen and paper calculator or some other tools. Then later on, right after this class, statics, you will be taking strength of material. That's another course uh, under the structural analysis series. So strength of material, they now not only just looking at the structure, being statics only, and they were now looking into the material of the structure. If it's built by stainless steel or aluminum, what is the material property of that? So in that situation, they're going to consider, okay, it's no longer rigid, all those materials. There's going to be some bending, there's going to be some elongation or shortening, so we call deformation of the structure. So this will be way more accurate, right, compared to statics, because statics, you consider everything is just rigid. You don't even thinking about material, you're just thinking about the structure itself. So you are built upon from statics to strength material when you're adding the material properties to it. And so this process could be very could be messy when you have a complex structures or building. And then some of us might be taking another course called finite element analysis. So you need a computer to analyze and using the tools, fundamental unit learning, static strength material, and using FEA, that's a short name for finite element analysis, to analyze it. Okay, so the goal for all of this is to do what? Is trying to make sure the structure doesn't fall, right? So this is a visual display how this is related. So structural analysis, and so far in this statics course, we will be looking at a structure, for example, a bridge. On the bridge there may be truck going by and there may be pedestrian walking on it. So those will be the loads we consider, or external forces. So we have like a truck weight, I might have pedestrian weight. Those are going to be the loads, and they will be supported by the bridge, will be supported by the columns or beams. So those are external forces. And then once we analyze a structure, we will be looking at internal force. Internal force is basically if you have a scissor, you go ahead and cut. If you have a hypothetical scissor, you go ahead and cut the structure, and you want to see at any arbitrary point on that bridge, what is going to be the internal force there, right? And what is the tension, what is the compression, what is the bending stress, shear stress, all of that will be. And why is that important? Why do we need to analyze internal force? Think about it. If we have an engineering disaster that happens at that particular point, the structure cannot withstand the external forces, right? Because at that particular point, that strength of that material cannot hold the stress at that particular point. That's strength of material. So if the stress at that time, at that point, is less than the strength, we don't expect a failure. However, if it's other way around, if the strength at that point is greater than if the strength at that point is gonna be less than the stress, well, engineering disaster happen. So that's, as a structural engineer, we need to understand that is going to be the process. That's going to be the system we're going to look at. We're going to understand, calculate the stress, and compare with the strength of the material. Then you evaluate. You're going to consider the safety factor and see if the structure will be sound. That's the general roadmap for the structural analysis. And that tells us why understanding focus on statics as a first step of structural analysis is critical, right? Because we needed to know what's the load reaction, what is the internal force can be.